promised to do a video recording on the application of matrices. This is per the agreement during our class time. And remember we said application of matrices are of three. We have what we call a simultaneous equation, solving simultaneous equation. So then we have the Markov analysis, and then we have what we call the input-output analysis. So these are the major application of Markov analysis. So now to help us in this, we are going to solve questions that will guide us to understand this concept clearly. Let us start with solving simultaneous equation. So we are going to do the question which was brought in our paper. That is let me show you the question that we are going to do here. I know you have these past papers, so we are going to be guided by these past papers. There is this question in year April 2023, question number 5B. So number one is to form the simultaneous equation. So a trader purchased 5 cartons of apples and 4 cartons of bananas. So we can say 7 cartons of apple plus 5 cartons of banana. At what price? The price was that 2,500. Then of course February we have 9 cartons of apples plus 6 cartons of bananas at how much? 43,500. So we are told now the cost of carton of apples and bananas using matrices. So we can use two ways. We can use what we call the Cramer's rule or inverse method. So the best method is Cramer's rule, where we are going to come and say 7, 5, 9, 6, like them in simultaneous, then AB, that 2,500, 43,500. So this is now divided in the form of matrix. To solve A will now, we take the 7 and 9. Remember A is represented by 7 and 9. Replace them with solution. So you say that 2,500, 43,500, 5, 6, get the determinant. We use the two-stroke to start for determinant, divided by determinant of the first matrix. So you get the determinant. How do we get the determinant here? So you multiply 6, that's 2,500, minus 5, 43, 500, that is the numerator, divided by 7, 6, minus 5, 9. So get the determinant using the calculator. So this is the two-stroke start for determinant. So you come and say 6 in bracket, that 2,500 minus 5, 43,500. So the numerator is negative 22. 500 divided by 42 minus 45. 42 minus 45, which is negative 3. So negative 22, 500. Divided by answer you get 7,500. So the A, which was the cost of carton of apple, is 7,500. For B, remember B is represented by 5 and 6. So now we replace with the solution. So now we take it there. So 7, 7, 9. Then we have, so now we take 5 and 6, where we have 5 and 6, replace them with the solution, which is the 2,500, 43,500. Now, determinant, and we have already gotten the determinant of the new denominator, which is negative 3. So that one we have seen, 42 minus 45, negative 3, which is the same as 5, 43,500 minus 9, that is 2,500. You get, so 7 in bracket 43,500 minus 9, that is 2,500. You get negative 2. So then you divide by. So this one was, we replace them with the solution, then we get 4,000 or such. So what you need to do, so remember to solve for A, you take the values of A, you replace them with solution. At the same case, to get for B, you take the answers, which was at 2,500 for the 3,500. You get the determinant, then you divide by the original body. I think this one we have done it in class, so we may not know so much of that. So the second application is what you call Markov analysis. Markov analysis, we are going to solve it using the equation to help understand Markov analysis. And remember, in Markov analysis, we say, this is now the second application, Markov analysis. We say it is already possible. This is where you project the future, or you estimate the future, forecast the future. But there are two conditions for you to forecast the future. You need the initial state. You need the initial state, or what you call the probability vector. You need transition matrix. Transition matrix, they are two. You say this can be of 3 by 3 or 2 by 2. And we say the property of this, you can find them in the notes. Number one, it is a stochastic matrix. That's what we say. Number two, it's a square matrix. Square matrix can be of 3 by 3 or 2 by 2. We also say it is empirically determined. In other words, through observations and all that. So let us have a question on this. Also to help us understand the concept, Markov process. We can do December 2028. December 2022. So please note that for Markov we need two things: initial state and transition probability. So we have December 2022, question number 3B. Higher. We are given an addition there. So the banking industry in a given country is controlled by three banks, where we have Faida Bank. So we can say Faida Bank. Let Faida Bank be represented by X1. Then we have Akiba Bank. That one can be represented by X2. Then we have the other one is Ahadi Bank can be represented by X3. Then we are told at that first December, what was the situation? That first December 2021, which will now be our initial state. Now remember, initial state is what we call probability vector. Probability vector is where elements add up to 1 and all of them are negative. So we have 30%, 50%, and 20%. Of course, now for this is the initial state. You can write them in fraction, you can write them in decimal, you can write them in percentage like we have done. So this is for Faida, Akiba, and then Ahadi. You can see what we are saying. They should add up to 1 or 100%. All of them are non-negative. So let us now come to transition matrix. So transition, we have X1, X2, X3, X1, X2, X3. So we are told a survey was conducted on market share of the three bank asset that first December 2021 and reviewed the following. Faida Bank, which is represented by X1, and retained 80%, 0.8, but lost 15%. And it's 5% to X2 and X3. Then we come to X2, Akiba Bank, which is represented by X2, had lost 10%, had lost to X1, 0.1, then 20% to X3. So how much did it retain? 0.7. Because remember, they should add up to 1. All low elements should add up to 1. Ahadi Bank had lost 5% to Faida, so this is 0.05. They are lost 0.05 to x2, but so if we are told they lost 5% to x1 and 5% to x2, then the retention is 0.9, because when you add this, you should add up to 1. So this is what we call transition matrix. You come up with transition matrices and we say it is a square, and this is a 3 by 3. Row element should add up to 1, as you can see, and all elements are negative. You can revisit what we did in the class. So the first question is determine the transition, that one we have it there. Number 2, market share. So for us to know the situation in that first December, so market share of the bank asset. So the initial state, if we have to go back, so it was 2020. Because for us to know 2021, we must know 2020. So then we say the new state depends on the preceding. For us to know 2021, we must know 2020. For us to know 2022, we must know 2021, and so on. So this one, to answer question number 2, shares at December, we need to take this and multiply by this, 0.3, 0.5, 0.2, we multiply by the transition. Then we have 0.15, 0.7, 0.05, then we have 0.05, 0.2, 0.9, you multiply them. So then you say x1, which is fine. Remember this is x1, x2, x3. So you take this, you multiply by this. So you say 0.3, 0.8 plus 0.5, 0.1 plus 0.2, 0.05. You get the answer for the first one. And remember x1 is spider bank. To get x2, you say 0.3. Multiplied by the second one, this one, plus 0.5, 0.7, plus 0.2, 0.05. X3 is 0.3, 0.05 plus 0.5, 0.2 plus 0.2, 0.9. Please, once you get the answers, you can write them in percentage or decimal. So that will have answered question number 2. So you are taking the initial state, you multiply by transition. Number 3, the steady state. Now we see a situation has come to a steady state. If you take x1, x2, x3, this one, you multiply by 0.8, 0.1, 0.05, 0.15, 0.7, 0.05, 0.05, 0.2, 0.9. If you can multiply, you get x1, x2, x3. That is a steady state. Steady state maanisha kwamba it cannot, you have come to equilibrium. Steady state is if you multiply the original the probability vector with transition and get the same, we say it is a steady state. And how do we go about it? I take this, you multiply by this, 0.8 x1, 0.1 x2, 0.05 x3 should be equals, when you take this and you multiply by this, should give you x1. And we know x1 plus x2 plus x3 equals to 1. Just like if they are 3 by 3, you add 3, if it is 2 by 2, add 2 should give you 1. This is what we can confirm here. When you add all these, they should give you 1 for 3 by 3, and for 2 by 2 the same. Higher. So what is x1? x1 will be 1 minus x2 minus x3. So that means our first equation will be 0.8 x1 plus 0.1 x2 plus 0.5 x3 equals to, now you replace them, x2, x3. So we take our work here. So this one we put right down together to be 0.8 x1 plus 1.2. Now you take this to the other side, 1.1 x2 plus 1.05 x3 equals to 1. Why are we equating to this? Because if you take this to the other side, work as simultaneous equation equated to 0. So that is the first equation. We now do the second equation the same. We now take this one multiplied by this 0.15x1 plus 0.7x2 plus 0.05x3 equals to x2. x2 equals to 1 minus x1 minus x3, because we have said x1 plus x2 plus x3 should be added to 1. So then 0.15x1 plus 0.7x2 plus 0.05x3 equals to 1 minus x1 minus x3. Put the right term together. Take this to the other side. 1.5x1 plus 0.7x2 plus 1.05x3 equals to 1. That is second equation. So we now do the third equation. Take this multiplied by the third column. So it will be 0.05x1 plus 0.2x2 plus 0.9x3 equals to x3. x3 in this case is 0. Remember, x3 will be 1 minus x1 minus x2. So you can say 0.05x1 plus 0.2x2 plus 0.9x3 equals to 1 minus x1 minus x2. Put the right term together. 1.05x1 plus 1.2x2 plus 0.9x3 equals to 1. You have three equations. Solve them simultaneously. So I can now bring them together. 0.8x1 plus 1.1x2 plus 1.05x3 equals to 1. Then equation here given 1.5x1 plus 0.7x2 plus 1.05x3 equals to 1. I now see is 1.05x1 plus 1.2x2 plus 0.9x3 equals to 1. How do we solve that one? So now we work for x1, x2, x3. So I'll take you back here because of the space. The same here, let me not delete that. So we now write it in form of matrices. So here we'll have, maybe I can write it here to make my work easier. 0.8, 1.15, 1.05, 1.1, 0.7, 1.2, 1.05, 0.9 matrices x1, x2, x3 should be equals to 1, 1, 1. I use the Cramer. You can use the inverse method or you can use the Cramer's rule. The inverse method we have a step, but let us use the Cramer's rule. To work for x1, you take the values. This one, you replace them with the solution. So you say 1, 1, 1, 1, 1, 1. The other one is 1.1, 0.7, 1.2, 1.05, 1.05, 0.9. Get the determinant. Divide by determinant of original matrix. 1.05. 1.2, 1.05, 1.05, 0.9. You get the determinant. So now this is where we apply calculator. Remember to get like this one, the denominator is 1. Eliminate this, get the determinant of this, the way I showed you in class, 0.7, 0.9, this times this, minus, in bracket, 1.2 times 1.05, you get negative 0.63. If the first one is minus, remember plus minus. So the second one, you say 1, 1. Eliminate this value, eliminate this. So you take this times this, 0.9 minus times this. So that is 0.9 minus 1.05. You get negative 0.1 115 plus 1.05 plus minus plus in bracket this minus this 1.2 minus 0.7 0.5. That's the numerator. Denominator you do the same. So you say 0.8. Eliminate this, so this and this, which is the same as 0.63 minus 1.1 in bracket, eliminate this, so this times 0.9 minus in bracket, remember this 1.05, you get negative 0.0675 plus 1.05 in bracket. Now eliminate element in that row, eliminate element in that column, so you get the determinant of what remains. 1.125 times 1.2 minus in bracket 1.05 times 0.7. You get 0.645. So this now you get 1. We may not do all of them because we follow the same procedure. Minus 1.1 in bracket, negative 0.15 plus 1 in bracket 0.5. You get 0.06 numerator in bracket negative 0.63 plus minus 1.1 in bracket negative 0.0675 plus 1.05 in bracket 0.645. You get 0.2475. So 0.06 divided by answer, you get 0.24. So that is x1. x1 in the long run is 0.24. Now to get, at least if you get the first one, it becomes easy to get the third one. Because now the third one will be, the second one, x2, you will replace them with now the second column. So the first column will be 0.8, 1.15, 1.05, 111, 1.05, 1.05, 0.9 determinant. For denominator, at least we have gotten the determinant to be this. We don't have to write this again. It will be too much work. Just indicate, divide by 2475. So you say 0.8 in bracket. Eliminate this value, eliminate this, so you are left with this 0.9 minus 1.5. You get negative 0.15 minus 1 in bracket. This one we headed somewhere, but we can. So eliminate value, so you are left with this and this. Get the determinant 1.15.9 minus 1.05 squared. Actually we headed somewhere. 0.675 plus 1.05. So 1.15 minus 1. This process is repeated. So 0.1. Then you divide by 0.2475. 0.8 negative 0.15 minus 1 in bracket negative 0.0675 plus 1.05 in bracket 0.1. Then you divide by 2475, you get 0.21. So at least you have x1, you have x2. Remember we have said x1 plus x2 plus x3 equals to 1. So if you have x1 and x2, x3 therefore it's 1 minus 0.24, 2.1. So you can say 1 minus 0.24 minus 2.1. You get it to be x3 is 0.55. You can give them in percentage, you can give them the way they are. So that is a nutshell of the question, which was the second question. So the other question, so that we can wind up on that. It's now application number 3. Application number 3 is what we call input-output analysis. So this one, please, you can have a look on it at your time. If you have any issue, you can get back to me. So now you can get to number 3. Number 3, which is the last one I do for this concept. It's called what we call the input-output analysis. I want to check this question from your papers so that we can easily understand. So there are more questions on Markov analysis, but for the interest of time, we may not have to do all of them. So we can only work with the sampling. The one we are able to do, we can do them. So the others, you can do them at your free time. Now, input-output analysis. Let me work on this question. If I don't find it, we can use another one. So let us use this. December 2023. Input, output analysis. And most likely we are going to be examining this. So please prepare that. So December 2023 question number 4a. We usually say under this one, the procedure is x equals to 1 minus a. These are in one note. D. X is the final output. A is called the technical matrix or technological matrix. D is the final demand. When you say 1 minus a, it's called a Leontief matrix. But the inverse of it is Leontief inverse matrix. So if you want to get, like in this case, so this is a matrix which can be 2 by 2 or 3 by 3. Like in this question, we had agriculture, we had manufacturing. This was then of course their production, then we had purchase, production, agriculture, manufacturing. So we are told an economy is based on 2 sectors. Agriculture, production of shilling, to produce shilling. Production of a shilling worth of agriculture require input of 0.3 from agriculture and 0.1 from manufacturing. Production of a shilling of manufacturing require 0.2. This is matrix. Remember, in some cases you may not be given matrix. So if you are not given matrix, go back to the notes and I've shown you how to get the matrix. So this is our matrix, which is our A. Already we have our A in our case. So if we have the A, we need to get 1 minus A. This is 2 by 2 matrix. So identity of 2 by 2 minus 0.3, 0.2. If it is 3 by 3, identity matrix of 3 by 3. This is 0.7, negative 0.1, negative 0.2, 0.6. Now if it is 3 by 3, in our questions I've shown you even how to develop matrices of this. So now to get the last, so this is 1 minus A. Now you get the inverse. To get the inverse, 1 minus A. Now if it is 3 by 3, please do the same. Inverse of 3 by 3. In our questions we have done several of them. So inversely, you get the determinant first, which is 0.7 times 0.6. Minus in bracket negative 0.1 times negative 0.2. So what's the inverse? 0.7 times 0.6 minus in bracket negative 0.1 times negative 0.2, which you get 0.4. So inverse is 1 over 0.4. Then you get interchange 0.6. 0.7, the other one you change sign, 0.1, 0. I mean this one you change sign, 0.2. So this one you can change, the way I showed you, but this one you just change the sign. This is the inverse. Now to get the x is 1, the inverse, 0.6, 0.2, 0.1, 0.7, multiplied by, we are told if the demand changes to 12 billion for agriculture, and 8 billion for manufacturing. So what is the final output? So x equals to 1 over 0.4. You take 0.6, 12, plus 0.1, 8, then 0.2, 12, plus 0.78. So what are you going to get out of this? So now our final case will be given as, so this one will come and say is the same as higher. X equals to 1 over 0.4 in bracket, multiply this, 0.6 in bracket 12, plus 0.1 in bracket 8. You get 8, and the other one is 0.2 in bracket 12, plus 0.7 in bracket 8. You get 8. So, now, x1, agriculture, which is the first one, 1 over 0.4 times 8. Manufacturing, which is 1.4 times 8. So you get they will be the same. So for in the long run, the new demand will be 20 billion, because they were billion, and this one will be 20 billion. And of course, we can get a question, like now there is a question that was examined on 3 by 3. This one you can refer to. So we may not do a lot of questions for now, because I want to show you something else which is separate from this. But if you go and do question number, you will find a question that was brought. April 2023, question 3A. So you just need, this is now 3 by 3. This one, this question, April 2023, 3A, this is a 3 by 3. So if it is 3 by 3, you need to come up with X, the matrix, and in this case, like the X, you have X1, X2, X3, X1, you come with 2A. A will be equals to, like X1 is 40, divided by, you get the total of X1. What is the total of X1? Like now, just I will not do it, just to show you. Total of X1 will be 40 plus 40 plus 40. Remember, you go to plus 680. You get this 800. Now for X2 is 40 divided by the total of X2. X2 is 40 plus 80 plus 80. 200, plus 1400. You get 1600. Then this one is 40 over X, the total of X3. X3 is 400 plus 1200 plus 280 plus 2120. You get 4000. Now this is for the first one. To get this one is 40 over 800, the total of X1. The other one is 80 over 1600. This one will be 80 over 4000. So this one will be 400 divided by 800. Then 1200 divided by 1600. This one will be 280 divided by 4000. So once you come with A, this will give us A. Then you use identity matrix of 3 by 3 to say 1 minus A. So you say 1, so like in this case you get 1, 0, 0, 0, 1, 0, 0, 0, 1 minus the answer that you get here. Then you get the inverse. So the other steps will fall. So remember we are saying 40 divided by the total of X1, 40 divided by, because this is X1, you are buying from X1, you are buying from X2, that's why we are saying the total of X2. So if there are more questions on this, please, we are going to revisit them. But for now, this is the major application of matrices as we agreed. I know we have tried to launch some of these, but please, you can study on your own. Let me stop at that point. If there is more question on this, please, you can always get back to me, or we can arrange to have a physical class. I take you through this. Thank you.